So just like we can multiply and divide radical expressions, we can also add and subtract them. But there is a slight difference. With multiplication and division of radical expressions, the only thing that we had to ensure was that our indices were the same on the expressions, meaning we had to be taking the same type of root. We had to be dealing with only square roots or only cube roots or only fourth roots, whatever. When we are trying to add and subtract radical expressions, not only do we have to have the same indices, we also have to have the same radicands in order to be able to add or subtract two radical expressions. So for instance, we could not add or we could not simplify an expression that included, say, the square root of x plus the cube root of x. So those are two different types of things. It's very similar to, or basically the same thing as the idea of being able to combine like terms. If you had an expression 3x plus 2x squared, you couldn't simplify that anymore because x and x squared, those aren't the same types of things anymore. They have different degrees on them, and so they can't be combined. Same way, if we had, like I just said, maybe the square root of x plus the cube root of x, we couldn't simplify that expression because a square root and a cube root are two different, essentially, degrees on that variable x. So let's do some examples. So here are three examples of problems where we want to either add or subtract two radical expressions. So let's take a look at this first one. Here we've got 7 times the cube root of 5 minus 4 times the square root of 5. Now because the indexes, or the indices on these two expressions are different, we're dealing with a cube root and a square root, we can't simplify this, can't be combined. So if you saw a problem like that, you could just say that you can't simplify it. Let's take a look at the next one. Here we're dealing with a square root of xy and a square root of xy. So this is one where we actually can simplify this expression a bit. There are a couple of ways to think about a problem like this. The way your book explains it is it talks about using the distributive property. So essentially what you're doing is you're saying, oh, look, there's a factor of the square root of xy here and a factor square root of xy there, which means that you can factor out 3x and 4x from both of those terms, and you're left with the square root of xy. And then, of course, 3x and 4x, those are like terms, so you could add them together. That gives you 7x. And then you've just got 7x times the square root of xy. Personally, I don't even think about this initial step here that involves factoring. I just noticed that we've got like terms here and here. We've got the square root of xy and the square root of xy. And actually, in this case, in this problem, we also have x times the square root of xy in both terms. And so if we start with 3 of them and we're adding 4 of them, then of course you're going to end up with a total of 7 of those things. Alright, last example. Here we've got 17 times the 5th root of 3x squared minus 15 times the 5th root of 3x squared. Because both of the indices are the same and both of the radicands are the same, again, we can combine, or we can simplify these two radical expressions. If we have 17 of them and we're subtracting 15 of them, then this is just 2 times the 5th root of 3x squared. Simple as that.